Hi everyone, it's almost noon. Before we head to lunch, it would be a good idea to relax for a moment and watch an educational video. We're already familiar with solenoids, or coils, and inductors. A solenoid has a quantity known as self-inductance, L. This quantity depends solely on the shape and geometry of the solenoid itself. Let's discuss it. Suppose the solenoid is connected to an electrical circuit. When the switch in the circuit is closed, an electric current begins to flow. A magnetic field is created in the solenoid. Its direction can be determined using the right-hand rule. If you've watched the tutorial video from the Physics of Magnetism series on this channel, the magnitude of the magnetic induction at the center of the solenoid's axis is B equal to mu0 In over small l. Small l is the length of the solenoid. We call it small l to distinguish it from L from self-inductance. This magnetic field penetrates the circular surface of the solenoid. The magnitude of the electric flux through that surface is phi equal to B times A, or mu0 In over small l. Now, assume that the magnitude of the flowing electric current changes. This change in electric current produces a self-induced EMF. From the previous series, we know that Li is equal to N phi. We can plug the value of phi into this equation. The left-hand side contains the value of I. The right-hand side also contains the value of I. We can cancel both of these values. L is equal to mu0 n squared A over small l. Note that mu0 is a constant. N is the number of turns. This determines the geometry of the solenoid. A is the cross-sectional area of the solenoid. This also determines the geometry of the solenoid. Small l is the length of the solenoid. This, of course, is the geometry of the solenoid. Thus, the self-inductance of a solenoid is determined by its geometry. It is determined by its cross-sectional area, the number of turns, and its length. In other words, the same solenoid will have the same self-inductance value. If we want to achieve a specific value of self-inductance, we can change the geometry of the solenoid. Nothing needs to be done to the electrical circuit. Hopefully, this tutorial has increased your knowledge regarding self-inductance. And don't forget to watch the next video.
I am waiting for a bus stop